Hello students, I am Navdeep. I am back again by taking my sixth part of chapter 2, that is structure of atom. In last video, we have discussed about the characteristics properties of a wave. I am just continuing with that part. So in last video, we have talked about that if a charged particle is moving, suppose the charged particle is moving in this direction, so it will create some electric and magnetic field which are mutually perpendicular to each other. Suppose if this is the direction of electric motion and this is the direction of magnetic field and this is the direction of propagation, so these three are mutually perpendicular to each other. In last video I told you about this one, that if this is like, this is the electric field and the perpendicular to which is, this is magnetic field and this is the direction of propagation. This is what, whenever charged particle is moving in a certain direction, so it will create electric and magnetic field. That's why such kind of waves are called as electromagnetic waves. So these are the properties of electromagnetic radiations. So very first that I told you that whenever the oscillating electric and magnetic field produced, due to which, because and particle is oscillating, that charged particle is oscillating which are perpendicular to each other, means the particles which are oscillating and produce the electric and magnetic field which are perpendicular to each other, both are perpendicular direction of propagation. This is what the direction of propagation, and the electric and magnetic field produced by the charged particle are mutually perpendicular to each other, as well as both are perpendicular to the direction of propagation of this charged particle. So this is the very first characteristic property of a charged particle propagation. Second thing is, it does not require any medium material to travel, as we talked about in case of water waves or in case of sound waves. So such kind of waves need a material medium to travel, but in case of electromagnetic radiations or electromagnetic waves, they do not require any medium material, means they can also travel in vacuum. Third property of the same electromagnetic radiations, like, as you know, a different type of electromagnetic radiations forms the different type of the spectrum, that is called as what? Electromagnetic spectrum, that we have seen later on. So this is what the kind of electromagnetic spectrum that is seen due to difference in their frequency and their wavelength. So depending upon the wavelength and the frequency, there are various kinds or different kinds of electromagnetic waves which can be characterized according to their wavelength and frequency that we will discuss earlier. Now, if we just talk about a simple wave, so what are the terms or the characteristics of a simple wave? Suppose this is what a kind of wave which is traveling in this way, right? So here it is taken as the line of zero disturbance. It is called as line of zero disturbance, around which the particles are moving to and fro or back and forth. So the upper part above this line of zero disturbance is called as crest, and the lower part is called as the trough. The similar way, it is also called as crest. Now, if from this point to this point we termed it as a single wave, this is what a complete oscillation of one wave. So the very first term is the wavelength, means the length covered by a wave. So suppose the wave starts from this point and ends at this point after covering one crest and one trough. So this is termed as lambda. The symbol for wavelength is taken as the lambda, this sign, right? It is written as LAMBDA, lambda, right? The symbol for this is. So the wavelength is defined as the distance between two consecutive crests or two consecutive troughs. If we talk about, this is a crest and this is a crest, so the distance between these two consecutive crests is called as the wavelength, or the distance between one crest and one trough. So this is called as what? The wavelength. So this is the wavelength and written as the lambda. As you know, this is simply the distance. So the SI unit of wavelength is meter. Is the SI unit. The next common term is the frequency. Frequency means the number of waves passing through a point in 1 second. Suppose I am taking this point, and in 1 second, how many waves are passing through this point only in 1 second, and that is defined as the frequency of that wave. Means the number of waves passing through a point in 1 second. As we know, the frequency is the number of waves passing through a point in 1 second. Therefore, its SI unit is second inverse. That is S-1 or Hertz. That is known as Hz after the scientist named as Heinrich Hertz. Next term is the velocity. What is the velocity of a wave? Whenever a wave is traveled, so it must travel a certain distance. So the distance traveled by a wave in 1 second is defined as velocity of the wave. So the velocity of the wave is known as v. That is the SI unit of which is meter per second. As you know, that's velocity. Second order velocity is meter per second. Already, as we know, the fourth term is known as the amplitude. So what is the amplitude? So the maximum height or the maximum depth covered by a crest or trough respectively. So this is the maximum height attained by the crest, termed as amplitude, and the symbol for it is capital A. In the similar way, the maximum depth covered by a trough is called as the amplitude. For a simple wave, for a single wave, both are equal, either the height of crest or the depth of trough. So the amplitude is taken as, is denoted as A. Here the frequency symbol is nu. This is nu, that is Nu, nu. And in this case, the amplitude is denoted as letter capital A, which is what? The height of crest or the depth of a trough. So, as we know, this is again the height, which is what? The length. Therefore, the SI unit of the amplitude is again meter. The next term is what? The wave number. So, wave number is the number of wavelengths per unit length, or if suppose I am taking a certain length, right? So how many waves are passing through it per unit length? Suppose I am taking as length as 1 meter. So how many waves are passing through this 1 meter length? So this is termed as the wave number, or it is also termed as the reciprocal of the wavelength. This is means what? That the wave number is denoted as nu bar. So wave number is denoted as nu bar. Wave number, which is what? The reciprocal of wavelength. So therefore, nu bar is equals to 1 by lambda. As you know, lambda is a wavelength. Wavelength unit is meter. So the SI unit of wave number should be meter inverse. That is meter inverse. This is what? The SI unit of a wave number. As we discussed earlier, that if various electromagnetic radiations constitute the electromagnetic spectrum, which can be characterized on the basis of their wavelength and the frequency. So now we have the various regions of electromagnetic spectrum, in which the lower line represents the wavelength and the upper line represents the frequency. So here we have various regions. So first of all, we have the gamma rays that belongs to 10 raised power 24 to 10 raised power 20 Hertz in frequency, and 10 raised power 16 to 10 raised power 12 in case of the wavelength. The second reason is the X-rays. The third reason belongs to UV rays, that is ultraviolet region, which is used, which is a kind of rays present in our sun rays. The fourth reason is infrared region, that is used for the heating purpose in case of the oven. Okay. The next one is the microwave regions, that is used in case of radar to provide the signals. The next, the number sixth reason is called as the radio waves, in which the two categories are there, that is frequency modulation, that is FM, and then amplitude modulation, that is AM. And these all kinds of waves are used for broadcasting. The next is what? The long radio waves having the much more higher than having a much more wavelength, that is compared to the radio waves 10 is power 0 to 10 is power 2, but here 10 is power 4, 10 is power 8 meter is the wavelength. So this is the difference between the various regions of the electromagnetic waves, but here only a very small fraction of the region that belongs in between the ultraviolet region or infrared region, that is called as what? The visible region, that belongs to the frequency as 10 is power 15 hertz, and the wavelength between the 10 to the minus 8 to 10 to the minus 6 meter. So very small fraction of these electromagnetic radiations, we come to know that it is what? The visible spectrum means what? That very small fraction of electromagnetic radiation we can see. Otherwise, to see all kind of these electromagnetic waves region, we need some special instruments. So in case of this visible region, I'm just broad categorize this in this way. So here again we are having the 7 spectrum, which is called as what? Vibgyor. So here is difference in between different regions of wavelength. That is, if we call that the violet color belongs to 400 nanometer, and in case of indigo, blue, green, yellow, orange and red. So here the red is the maximum spectrum formed band whenever the wavelength lies between 700 to 750 nanometer. This is what the visible spectrum means, the color, the light through which we can easily see. Whenever we talk about the 3 characteristics, that is the wavelength, frequency and the velocity. For example, whenever any ray or any wave is traveling in a certain medium, so as we discussed earlier, that it doesn't require any medium material like sound wave or water wave. So whenever any electromagnetic radiations move in vacuum, so all the waves, whether they are differ by wavelength or frequency, must travel with the same speed, that is equals to the speed of light, which is termed as 3 into 10 raised power 8 meter per second. Means all the electromagnetic radiations or waves are travel the same speed in vacuum, that is 3 into 10 power 8 meter per second. Therefore, we come to know a relationship between the frequency, that is nu, wavelength, that is lambda, and the speed of light, that is c, is equals to nu lambda. That is, the c is speed of light, nu is the frequency, and lambda is the wavelength. We can also change this relationship as, for example, I'm just taking space. Okay, now, so c is equals to nu lambda. If you just take lambda here, c by lambda is equals to nu, and here c into 1 by lambda we can change it to as nu, or c into 1 by lambda is equals to what? 1 by lambda is taken as wave number, that is nu bar. So here it changes to c into nu bar is equals to nu. This is the another relationship between the speed of light, wave number and the frequency. Clear? So this is the relationship between, it is very useful to find out whether the wavelength, whether the frequency, if the speed of light is known, that is 3 × 10⁸ meter per second. So this is what the part 6 of this chapter 2, that is that is structure of atom. If you like this video, then like, share, and if you have any doubt, then ask in comment section. Thank you.